Thanks for joining us to another webinar organized by Princeton here. And today we have Benjamin Golub with us. Hi, Ben.
Hi, great to be here.
Great, Ben. So Ben will talk about modern AI for economic research, I guess more broadly for social science research. And he will provide an overview of tools. So I asked Gemini, how would economic research look like in 2030? And here are some ideas I collected from the interaction. First, of course, LLMs will impact a lot the ideation, so to create ideas, to brainstorm. But the bigger change is, will we still read papers or will we chat with papers? And will we have AI-enabled dashboards instead of papers? In terms of literature reviews, we might have some living knowledge graphs, and the theory might also look very different. So rather than having rational agents in the models, we might have LLM-based agent-based models, where each agent has its own personality. It might also be boundedly rational and form expectations based on some textual analysis the agent conducts inside this model. Experimental economics might also be very different. Rather than running only with human subjects, we might create synthetic subjects. And with these synthetic subjects, we can, conduct thousands of pilot studies. Econometrics might be very different. We might have some causal inference 2.0. As we do already, we use a lot of unstructured data, but we will use way more unstructured data compared to what we're using now. We might scan for instrumental variables and get suggestions from the LLMs. We might conduct a lot of double machine learning. And then when we go to the peer review, rather than asking some referees, we might also have some AI-augmented refereeing system. And I think Ben will talk more about this, in particular when he talks about his new baby, refine.ink. How do we evaluate which papers have more impact than other papers? Right now, we mostly go on the publication process and the citations, Google Sites, for example. I think in the future it will be much more how many GitHub downloads will the paper get, and the underlying code. Will people download the underlying code, build on it, and incorporate it in the next paper? So GitHub downloads might matter much more. So we decided actually to split Ben's webinar into three parts, three standalone parts. One part is about a tutorial how to use Cursor to an AI native environment with access to your files, and you choose models to run agents tasks. That's one part we will talk about here. The second part, or some other part, is to really talk about refine.ink, how to generate referee reports to academic papers even before you submit it. And in particular, to go dive deep, these LLMs allow you to dive deep in the appendices and the proofs, to identify errors in the proofs, in the empirical strategy, about the clarity of the writing and consistency. And another part, another video we will generate is about prompting LLMs, how to best prompt LLMs. Let me start with this because it also feeds into how to use the cursor. So what are the heuristics for working with AIs? First of all, important to keep in mind, LLMs are brilliant, but they're limited junior assistants. They're strong at bounded tasks, but weak on high-level project context and norms. This is taken directly from Ben's insights. The models have certain failures you have to be aware of. They're overconfident. They rather guess than to say, I don't know. They're not like Socrates. And they also suffer from tunnel vision. They optimize the local instructions at the expense of the real objective, the bigger real objective, because they lack the broader context. One has to prompt for rigor. So one way to do that is to assign a certain role play and also assign the audience. Tell the LLM for what audience this prompt is made and what role it should play. And one also would like or has to get a better outcome, split the task in steps So force stepwise planning. Decompose the task. And finally, ask the LLM to write some handoff reports. You collect all the output, ask for a handoff report, which you can give to the next report. But very importantly, don't fight the model. If you get the wrong answer, it will poison future outputs. So importantly, you should start a new chat. Don't continue the old chat all the time. Start a new chat. That means you have to actually run several chats simultaneously or in parallel. And that means you need an instrument or a software to orchestrate several chats which you would like to run in parallel, which you start anew, and to manage these chats. And that's where we go to this part of Ben's webinar. You want to create an AI native environment using Cursor. You want to move beyond simply chats or browser chats with using, for example, ChatGPT or Claude or Gemini 3.0. And here Cursor is a useful tool, and what Ben will provide is a tutorial how to use Cursor in this part of his webinar. How to use step-by-step prompting inside the environment of Cursor and use essentially parallel chats. And Cursor is the way to better orchestrate these AI tasks. So you're the conductor and orchestrating with using Cursor many of these AI tasks. So you're better than juggling many different chatbot tabs, have everything in Cursor, and then enable retrieval augmented generation. Ben will also show you how to connect it to GitHub repositories, also connect it to LaTeX text, to code, and BibTeX files. And this enables model selection by task. And what you want to do is to use the LLM which is best for particular tasks. So for example, Claude for Anthropic is very good in coding and workflow task management, while GPT is very good in math-heavy tasks. And you would like to use different LLMs for different tasks. So with this, let me conclude, and I've used already from the other parts Ben's insights, pass it on to Ben, who will really tell us how to use Cursor the most effective way to orchestrate all the parallel tasks you want to conduct. Ben, the floor is yours, the mic is yours. We're looking forward to your explanations.
I'm going to now move to taking some of those prompting philosophies, but in implementing them in a much more powerful way through tools that are designed for it. So the way I worked until a year ago is mostly Overleaf, sometimes Dropbox. All my co-authors and I would share a repository in this kind of tool. My sophisticated colleagues who do empirical work often use GitHub, which is the industry standard for software. And so so one thing that you probably know is that, or many of you know, but I'll remind those of you who don't, is that you can connect these two. And the main reason that's useful is that GitHub is, since it's the meeting place of software engineers, the software companies that the AI native environments that are designed primarily for software engineers are great at linking to GitHub. So GitHub can be sort of a waypoint in linking our, you can bring it in from anywhere, but I'll show you how I brought my stuff in from Overleaf through GitHub. So here's the process. And actually, before we go through the process, what you get once we can get into Cursor. So I claim Cursor is this magic machine. That the value of getting to Cursor is that Cursor is a much better orchestrator of tools than your out-of-the-box chatbot. So you can talk, an LLM running in Cursor can basically call a lot of different tools and critically do that in the context of your repository. So for example, if I'm writing a paper, Cursor has access, the LLMs will have access to all of my different bibliography files and my tech file and perhaps auxiliary code that I've written. And so those abilities take all of the strategies we discussed previously and really take them to a new level. So let me show you, even if you're a big AI user, on the next slide we'll see. So first of all, let me show you the process of actually, connecting the two. So in Overleaf, I was working on this paper. I click integrations on the left, and then what opens when you click, we can just keep it. It's just all slides. Yep. We pop up this panel and we see GitHub there. So you have to create a GitHub account. It takes 5 minutes. And once you have a GitHub account and you click GitHub integration, if you haven't uploaded this repository, if you haven't exported this repository before, it will say, once the first time you do this, you'll link your accounts, and then it'll say, oh, I'm happy to put this repository of yours into GitHub. And let's just go back. And so you'll name it something, and then you'll click Create GitHub Repository. And that's it. You can go on the internet and check that Overleaf synced everything, just like Dropbox synced, and put it on the GitHub repo. Then you download Cursor. So what's happened in between this last frame and this one is you've downloaded Cursor and opened it. And the first thing it offers you is clone repo, right? So you can click clone repo. In the top bar, it'll show you the option of cloning from GitHub. And then immediately, if you click that, you'll see all your GitHub projects. And since this is the one that I uploaded last, mine is at the top. So I just click that, and after telling it where you want that content to be saved, you immediately get a window that looks in many ways like Overleaf. So you have your raw tech code, you have your PDF preview. Now, one thing I realized as I was preparing this presentation is that the cursor has this hacker dark view. And so if you go to the next slide, you can change the theme. So I put on a light theme. So if you use Cursor, maybe even as a regular Cursor user, you haven't thought of doing this. So this might be, for some people, easier on the eyes. But then the other thing is, Cursor is built on top of VS Code, which has all these amazing tools for various applications. And so if you go in that tool, the thing that looks like a little box with many tools, still on the previous slide, we see LaTeX Workshop, and so you can download that, and that'll give you great tools for synced preview and all of that good stuff for LaTeX. So you can just download and install that. Once we've done all that, we basically have
So you still use Overleaf then? You still need Overleaf, or everything is in Cursor now?
Once you've done this, you can just be in Cursor.
Okay, so
but some of my co-authors are still on Overleaf, so I keep the connection.
I see.
Okay. So once we're in here, now we'll see what Cursor is good for.
This is like a BibTeX file, no?
Yes, I have a BibTeX file open, so it has access to all of my, you can edit everything. So let's go to the next slide. Just like Overleaf, this thing will show you your full list of, it'll show you, your whole folder structure. But most importantly, on the next slide, what Cursor has is this panel, the agents panel, and that's where all of the AI happens. So this is a chat, just like a chatbot chat, where you can talk to the AI, but in contrast to Claude Sonnet, it automatically has access, as I said, to all of your paper materials. So let's see how to use this.
So this is like ChatGPT 5.2, but
so
I can
yeah,
also
the model selector actually
switch on different.
I'm sorry, say that again?
Gemini. I can switch to different LLMs.
Exactly. You can select. So let's advance, and we'll see what we can do. So the first thing I did actually is I changed to Opus because Opus, the latest Claude model, is very good at long run work. That's not too that's not like too genius level. But here's an example of such a job. I say find all the LaTeX comments in my main file v7.tech, which start with assistant. I just leave it notes in my file like I would to an RA. And I say, I've left some requests to insert proper references. And so in each case, identify the paper being referred to by searching the web. It can just do that. And create bibtech entries in refs.bib. It can do that, and proper citations using the cref package. And I tell it to basically do a kind of higher level thing, which is make these changes and then try to compile the document and only stop when any errors it may have introduced are and this just, if you just click it, it's hard to sort of demo this, but it just works. So let's do something a little more ambitious. So that you can try that on in the privacy of your own home. Let's do something more ambitious. So here I've selected GPT 5.2 because I need someone really smart for this. And model differences. GPT 5.2 I think is the best at math basically right now. Claude is really good at coding. And Gemini, the latest Gemini I don't understand well yet. It's quite good, but I don't have strong feelings about it relative to. So here's an example again of good prompting, but now working in Cursor. Mm-hmm. So I say, you're a probabilist statistician working on proofs for this paper. And what we're going to do is we're going to write preparatory notes to write a proof of something in the paper. And your audience, and this is something that's recent research on LLMs has shown, that actually more important than giving it what kind of a role play of who it is, if you tell it it's writing for an expert of this type, just imagine yourself writing to a co-author who's really expert in statistics. Mm-hmm. You're going to be careful about the statistics, right? And so, and then I tell it, produce a markdown document with some strategies for proving this proposition. Now, I actually did this yesterday, and the proposition was similar to other stuff in the file, but did require creativity. So now, one very important thing here to learn about Cursor, one thing we haven't done yet, is I haven't given it any context. Unlike in Claude, I would have to paste in the paper. So if you want to give it context, what you can do is go to your file list. Here I've selected the tech file, v7.tech at the very top there, and right-clicked it, and then I can add that to Cursor Chat. So if we click that, we'll see what happens is.
So add to file to Cursor Chat, this thing?
Yeah, add file to Cursor Chat. You click that, and what happens is a little tile appears there in your chat, which basically attaches that whole paper as being available. So Cursor can search on its own, and it will trawl through your folder looking for useful things. But if you want to give, if you want to point its attention at something like where the proposition is in this case, you can do that. And you can also select only a part of your tech file and put that in context. And that's just one click, right? So let's go ahead. There's some other prompting here which you guys can look at in the uploaded slides. Now, a very critical feature of a tool like Cursor is that it does something called retrieval augmented generation, which means that it doesn't put the whole folder into context. It has it available, and it does an embedding of it so it understands roughly what various stuff is about. Like it embeds it in a semantic space. And then as it's thinking about this task, it's going to access different parts of your code base, in this case your academic paper folder, pulling in stuff like, let's say, a previous version of the paper where you had some relevant ideas or whatever. It's just going to have the freedom to do that. It can be annoying, actually, because you can't control where it's going to look. But let's advance and see how that actually looks in practice. So after you give it this task, you see what it's saying is grept, grept, grept. That means it searches for various strings in your file. And then it read various chunks of your document, loading them one by one into smaller contexts. And then it talks to itself a lot in the background about what this all means. And then it says, hey, you already have an impossibility result very similar to the one that you seem to want to prove. So, I'm going to now use that and write.
So that's within your paper, the good news.
Yes. Now, that's not it. What's interesting is that's not, of course, yes, in my paper it found something relevant. It's exactly the closest thing. And so it identified, okay, I basically need to mimic. I need to mimic this. And I hadn't told it that, but after thinking, it kind of focused on the right context.
Mm-hmm. So, but does it also go outside of your paper?
Of course, it can use all its knowledge generally, and it can even do web search. So, yeah. Okay, next slide. So I got, I get what I asked for, which is a background document. Oh, and by the way, what I was trying to produce here was not a proof, but the first step, which is a background document giving all the context that a clever person would need to come up with a proof. So it's produced that, now it's short. And now in the next prompt, on the next slide, I can say, okay, you're the same guy. Now you want to use the information in background to formulate a proof. And we're not yet writing the final proof, but just the plan. And if you write a really good plan, we'll succeed, and your audience, a careful assistant professor of probability, will be able to implement it if it works. So this is helpful for me because I can see these plans. I have a good sense of whether they're going to work, and then based on that, I can direct it. It is very helpful that we produce the background document because now it can focus all its thinking energy in this step on making the strategy. Otherwise, it would also have to collect the context, and in my experience, it would perform less well. Okay, so this plan succeeded. It gave me some strategies. I gave it some feedback on the strategies, which we see on the. One cool thing actually is if you do this management of the bureaucracy, in proposing the high-level outline, so this is not the file it produced, but just its quick notes on it. It says, look, the document I produced includes an important question for you. Do you really want what you formally wrote, or do you want more like what your prose around the proposition said? It detected a difference, and that's a good thing to resolve before I go to proving it. So I find that even for me, just as a researcher, if I go from high level to low level in steps, it helps me organize. It helps me organize my thinking and kind of, make important decisions rather than just trusting it. I mean, it will use its intuition to make those decisions for you if you tell it to do it in one shot. But typically, you won't love those decisions because you really need. Often, it's a preference thing, not even a correctness thing. Okay, so then I give it answers, and so on. Okay, I'll answer a question from the chat, which is relevant. So there's a bunch of tools like ChatGPT Codex, Claude Code. I'm a Cursor user, and so to be completely honest, I can't give you good contrast. Cursor. What I like about Cursor is that it's completely agnostic. It lets you use any model you want. And often mixing and matching right now for me Claude Opus and GPT 5.2 is very useful. That's the main advantage I see to Cursor. Otherwise, the tools are very similar. So once you've learned to use one, and another point I want to make is that they're daunting because they're power tools for professional engineers, but chatbots are amazing at guiding you through them. So you can take a screenshot and say, okay, I just downloaded Claude Code. I have no idea what to do. Here's what I see. What would you advise me to do? And anybody's chatbot, it doesn't have to be Claude's, will give you good guidance. So I found it a very effective way to get technical support for tools that otherwise would be intimidating to me.
Concerning ChatGPT, I mean, there's this $20 version, the $200 version. You think a $200 version is really, you need it?
So what I like about Cursor is that you pay, Cursor also has Cursor has a $20, or Cursor has multiple tiers, but they have pay per use above the nice thing about this is when you use the models, you're just paying per usage. And so at the end of the month, you get a Cursor bill. So actually, I think the most cost-effective thing is Cursor, and just use the models and it'll charge you by usage.
Okay.
Okay. So one thing I want to say, I'll take the last 5 minutes. I'll just tell you one thing, just for fun. I said, okay, we now proved our impossibility result. I just want you to give me an illustration that it's right by trying some reasonable strategies and verifying that what I claim to be impossible is impossible. Just do the whole thing. This is a one-shot prompt. I say, here's a simulation instruction. Draw a matrix, generate some strategies, show that none of them do what's supposed to be impossible. And you see this last paragraph here in the prompt. I say, orchestrate a good software engineering team with specs, design documents, etc. Put your work in this subfolder. I clicked, and there's this plan option where you can just, rather than agent, select plan, Claude will orchestrate the plan, you will approve it, and then it will do it. And this worked for me. I got a perfect illustration of my negative result in just one shot. So as you can see, despite all of the stuff we've been talking about with holding it by the hand and prompting, for things I know it's good at, like this kind of simulation, once everything is well specified, you can just give it one high-level overarching instruction and trust it to finish.
But then you went back to Opus 4.5 instead of ChatGPT.
Yes, because it's code. Because this is coding.
It's coding. Okay.
Yeah. All right. Let's jump ahead. I want to. You guys can look at the slides to see all of the cool. Just one thing to mention, like if you have it realized, it was coding in Python. It realized it didn't have this stuff on the left. It realized it needed to install some stuff. For example, the numerical routines for Python. I had given it permission to just work in the command line, and so rather than me having to futz around with installing stuff, it just does everything. It's just and in the end, it just worked. So for those of you who understand the command line but aren't masters at the terminal, letting these tools just do their thing for basic things like installing the background libraries you need, they just do it correctly, and so I found that very powerful.
The second part, or some other part, is to really talk about refine.ink, how to generate referee reports to academic papers even before you submit it. And in particular, to go dive deep, these LLMs allow you to dive deep in the appendices and the proofs, to identify errors in the proofs, in the empirical strategy, about the clarity of the writing and consistency. And another part, another video we will generate is about prompting LLMs, how to best prompt LLMs.